Good morning, guys. In this video, we will start talking about a new terminology, which is the moment of inertia. Now, what is the moment of inertia? Basically, guys, if I start by the mass moment of inertia, it is by definition equal to the torque needed to do a rotational motion with an acceleration. Of course, here I'm talking about the angular acceleration because this is a rotational motion with an angular acceleration of 1 radians per second squared. So the mass moment of inertia is equal to the torque or to the moment needed to do a rotational motion with an angular acceleration of 1 radians per second squared. Now guys, if I want to make an analogy between the rotational motion and the translational motion to find what is the physical parameter that is similar to the torque but in the to the moment of inertia but in the translational motion. I know guys that the mass is equal to the force needed to do a translational motion with an acceleration of 1 meters per second squared because I know that F is equal to ma. And this means, guys, that the mass in translational motion is similar to the mass moment of inertia in the rotational motion. In fact, guys, the torque is similar to the force and the angular acceleration is similar to the translational acceleration. So that's why, guys, what you should do is to always make an analogy between the rotational motion and the translational motion to understand the physical parameters. In other words, guys, the moment of inertia is the resistance to make a torque or a moment. So this is a resistance like the mass. If I have a huge mass, this is also a resistance to do a translational motion. I need a very large force to overcome this mass in order to do the translational motion. And this is also applied for the rotational motion. So the mass moment of inertia or the moment of inertia in general illustrates the resistance to do this rotation. Now here, guys, since we'll be talking about 2D cases and like the centroid, we'll be talking about some irregular shape or some regular shapes in the area, and we need to find the moment of inertia like we did for the centroid. So we will be talking here about the area moment of inertia, and usually, guys, the area moment of inertia is used in bending moments. So of course, if I have a beam and I put some load, this beam will do bending. So the area moment of inertia is used in bending purposes, and in fact, guys, the area moment of inertia I is used in order to find the stress. So as we said in the previous chapter, if I have the bending moment M, or if I have the shear force V, I can find the stress, and then from the stress I can know if this material can handle this load or not. Basically, guys, the shear force will give me a shear stress, alright? And then I will compare the shear stress with the strength to find out if this material can handle the load or not, while the bending moment is used for normal stress. And then I should compare this normal stress to the strength to find out if this material can handle the load or not. So basically, guys, in order to find the normal stress caused by bending, I should know I, because in the equation of sigma bending, you will have I. It is basically my over I. So guys, in order to find this I should do an integration. How? Basically, if I need to find the moment of inertia around X, so I should know the distance between this area and X. Of course, guys, if this distance is large, then the torque is large, or the bending moment is large, then the moment of inertia will be also large. Which means, guys, that I Ix is equal to the integration of y squared dA. Now, if I have several areas and they are all regular and their numbers is not infinite, so I can, guys, replace this integration by the sum as we did in the case of the centroid. So basically, guys, Ix is equal to the integration of y squared dA, and Iy is equal to the integration of x squared dA over all this area. Okay, like this case, so you can divide this area into small dA, and then for each dA you should define the distance between this dA and x and this dA and y, and then you can find Ix and Iy. Now, guys, why I have Ix and Iy? Because in fact, guys, I can have a bending moment around x and a bending moment around y, or only a bending moment around x. So I should, guys, know which I should use. So if I'm doing the calculation of the bending moment around x, this means that I need to find Ix in order to find the stress. If I need to find the bending moment around y, then I should use Iy in order to calculate sigma in y direction. So, guys, in fact, I have two area moment of inertia, one about x and one about y. Now, before, guys, solving some problems on how to find the area moment of inertia of a certain shape, I want you guys to memorize these rules. So let's start by the first one. I have a rectangle here, and I need to find Ix around what? What is x here? It is the x-axis passing through the centroid, and I need to find Iy. Y is the y-axis passing through the centroid of this rectangle, and of course I know that the centroid of this rectangle lies at b over 2 and h over 2. This means, guys, that Ix is equal to 1 over 12 bh cubed, and you should memorize it, and you should also memorize Iy, that is equal to, you should switch h and b, and then Iy will be equal to 1 over 12 hb cubed. And if I have a circular area, then Ix is equal to Iy, because here I have a symmetry, and it is equal to pi r4 over 4. Now, if I have a triangular shape, you should pay attention, guys, because if b here, if I have this triangular shape, then, guys, Ix passing through the centroid will be equal to 1 over 36 bh cubed, and what will be b? It is the base parallel to x, and h, of course, will be the height. Now, if I need to find Iy, then, guys, h will be parallel to y, so I should switch b by h. So, guys, you should memorize them, but before doing this, guys, before memorize them, let's prove one of them using the integration method. So I will prove Ix, okay? So I will take a rectangular shape and prove that using the integration method of Ix, that Ix is equal to 1 over 12 bh cubed. And then, guys, if you have another shape composed of these regular shapes, the rectangular, circular, or the whole, the triangular shape, then you can directly, guys, use all of these rules because you are memorizing them. Let's do the proof of Ix in the rectangular shape.
Guys, I want to prove that Ix is equal to bh cubed over 12 for this rectangle, and then of course you can do the second one by yourself because it is the same, only you should switch b and h. So what I'm gonna do, guys, I'm gonna start from the definition. So I know from the definition that Ix is equal to the integration of y squared dA. So this is the definition of Ix, and this should be over A. So what I'm gonna do, guys, I'm gonna take a differential area. This area basically, guys, is dA. It has a height of dy and a length that is equal to b. Now, if I do the integration over this area and I substitute dA by this value, so dA here is equal to b dy, and b is constant, then this means, guys, that I can remove b from the integration. So it is equal to b integration of y squared dy, and y, guys, is going from minus h over 2 to plus h over 2. So if I do now the integration, and since b is constant, then the integration of y squared dy between minus h over 2 and plus h over 2 is y3 over 3 between minus h over 2 plus h over 2, and this is basically equal to b h cubed over 8 minus h cubed over 8, so plus h cubed over 8, and this means, guys, and of course don't forget over 3 here, and this means, guys, that this is 2h cubed over 8 or h cubed over 4. H cubed over 4 times b over 3 is equal to h cubed b over 12 or bh cubed over 12, and this is the first equation. Now for the second equation, what you have to do is to take a differential. Since it is around y, then you should take a differential area parallel to y, and this differential area will be what? Will be basically h times dx, and of course the distance will be x, and then you will do the same method. So the integration here will be between minus b over 2 and b over 2 of h will be before this integration x squared times dx, and this will give me basically h b cubed over 12, so you can do it by yourself. So guys, you don't have to prove all these rules, you should only memorize them, and you will use them in the following video where we will be solving the problems of this chapter. Thank you.